Our little sample utility app, MyWorld, provides a frame of reference for understanding concepts such as frameworks and to show how the app lives and dies in the iOS system. So let's step through the app life cycle. On the left, you see the UI kit. This is a framework. A framework offers common code, providing generic functionality. iOS comes with a set of frameworks for incorporating technologies, services, and features into your apps. The framework is designed to easily integrate your code with it. And with the framework in place, all you need to do is add the specific functionality that you want in the app, the content as well as the controls and views. You add this stuff to your framework. The short but happy life of an iPhone app begins when a user launches it by tapping its icon on the home screen. As you see at the top, user taps application icon. The UIKit framework and the system launches your app by calling its main function. You can see the main function by opening the MyWorld folder, then opening the supporting files folder, and then selecting main.m, as we've already done. The code appears in the editor area, as shown. The main function is where it all begins. Now, it does only three things. First, it sets up an auto-release pool in this statement. Next, it calls the UI application main function to create the application object and delegate, and to set up the event loop. The template uses the first nil as the principal class name, so that UI application is the assumed name. And it specifies the second nil to load the delegate object from the application's main nib file. Let's see what this UI application main function is all about by choosing Quick Help from the Help menu. You can see that it takes the arguments argc, argv, principal class name, and delegate class name. We use nil as the principal class name so that UI application is the assumed name. And we use nil for the delegate class name to load the delegate object from the application's main nib file. Now we can close the Quick Help menu by clicking the X in the upper left corner. The third thing it does is release the auto-release pool in this statement. So that's what the main function does. And to be honest, this whole main function thing isn't something you even need to think about. What's important is what happens after the UI application main function is called, which is this function here. Now let's go back and look at that app lifecycle again. With the UI application main function, the application delegate, which is MyWorld App Delegate, receives the message application did finish launching with options on the right-hand side. This is where you start putting your code. The message tells the delegate when the application has launched. In this step, you initialize and set up your application, and you have choices. You may want to display your main application window, or you may want the window to look the way it did when the user last exited the app. So let's take a look at where the application did finish launching with options occurs. First, let's close the debugger pane, and then select myworldappdelegate.m file. This is a delegate object. It's a custom object that you code. It's responsible for some of the application level behavior of your app. You can see that the application did finish launching with options message is received here. And here, where there are two comments, is where you would do an override to customize your app after the application's launch. You might want to, for example, restore the state of the app before displaying the main view again. This is also the part of the code that creates the main view controller and the main window. The next step is for the UIKit framework to set up the event loop. Let's take a look at that app lifecycle again. The event loop is the code responsible for polling input sources. The screen, for example, or user touches. Events such as touches are sent to the object, say a controller, that you have specified to handle that kind of event. These handling objects, which would be on the right-hand side, contain the code that implements what you want your app to do in response to that particular event. A touch in a control may result in a change in what the user sees in a view, or a switch to a new view, or even playing a song. The event loop continues until it is interrupted. In iOS 4.2 and newer versions, your app must be able to handle situations where its normal processing is interrupted. The interruption may be temporary, such as an incoming FaceTime call, or a calendar alert, or the user pressing the sleep-wake button. Or it may be a more permanent interruption, such as when the user switches out of your app and your app begins the transition to its background state, where it is suspended to conserve power but remains in memory. When an interruption occurs, the system asks the application to quit its foreground state. The system sends a message, application will resign active, and that gives you the opportunity to do things in your code, such as save the user's data and state information. By state information, I mean saving where the user was in the application. You need to remember that whether the application is interrupted or sent to its background state or terminated, saving is important, because when the time comes for the app to launch again, what happens is that UI application main sends the application delegate the application did finish launching with options message, so that you can then restore the app to where the user left off. When the user performs an action that would cause your app to quit, such as transferring to another app or pressing the physical home button, UIKit notifies your app and begins the termination process. With iOS 4.2 and newer versions, the system doesn't seek and destroy your app. It is simply moved to the inactive state and then the background state. But under some circumstances, your app can in fact be terminated. In any case, when the user performs the action that would cause your app to quit, your app receives the application did enter background message. When you create a new project using a template, which is quite the normal state of affairs, all of this basic app environment is already included. That means when you launch your app, an application object is created and connected to the window object, the run event loop is established, and so on, despite the fact that you haven't done any coding. Most of this work is done by the UI application main function. And here's a blow-by-blow description of what it does. First, an instance of UI application is created. UI application then looks in the info plist file, trying to find the main nib file, which is the user interface file. To see the info plist file, we can select My World Info plist in the Project Navigator. The information in the file appears in the editor area. UI application makes its way down the key column until it finds the main nib file base. Here it is. It peeks over at the value column and sees that the main nib file base name is main window. UI application then loads mainwindow.xib, which is right here in the Project Navigator. By selecting mainwindow.xib, we see it in the interface builder, which appears in the editor area. This nib file is what causes your app's delegate, the main window, to get created at runtime. To see the inspector pane in the Utilities area on the right side of the workspace window, click the Show Hide Utilities button. Now we can select Files Owner in the Interface Builder's dock. We do this because we want to see information about the file's owner. In this case, the file inspector fills the inspector pane showing information about the file. The file inspector shows information about the file, but the identity inspector gives us a bit more information. We click the Identity Inspector tab to see the Identity Inspector in the utility area. By the way, we can also choose these inspectors in the View menu under Utilities. For example, here's Identity Inspector. The Identity Inspector shows information about the selected object's class, and that would be UI application. Well, what this means is that the file's owner, which is the object that's going to use or own this interface file, is of the class UI application. This object isn't created when the file is loaded, as are the windows and views. It's already created by the UI application main object before the nib file is loaded. Again, you didn't have to do any coding for this. UI application objects have a delegate object that implements the UI application delegate protocol. Specifying the delegate object can be done from Interface Builder by setting the delegate outlet of a UI application object. To see that this has already been done for you in the template, click Files Owner, and then click the Connections Inspector, which is the Connections tab at the far right. You could also choose View, Utilities, Connections Inspector. As you can see, the delegate object is set to My World App Delegate. Only the My World App part is visible. So the delegate object has been specified. Next, let's look at the first responder. This is a proxy object that is constantly updated while the app is running. usually to point to the object that the user is currently interacting with. If, for example, the user were to tap a text field to enter some data, the first responder would become the text field object. Next, let's look at the application's delegate, My App Delegate. What's happening here is that an instance of main view controller here set to be the application's view controller. The view controller is where you will put your code to control the views of your app. Next, let's click the window object. To see and change the window's attributes, you click Window and then click the Attributes Inspector at the top of the inspector pane. And that's this one here. The window has its background set to black, as you can see here, and the status bar up here is set to gray. If you notice also, the window is not visible at launch. So what happens here is that UI application loads this XIB interface builder file by first creating My World App Delegate, creating window, and sending My World App Delegate the application did finish launching with options message. My World App Delegate initializes the window. Let's take a look at this code. Here we have the header file for My World App Delegate, which defines the interface for the My World App Delegate object, which conforms to the UI Application Delegate protocol. It also defines the properties of the outlets for window and main view controller. The My World App Delegate implementation file creates the window and the main view controller and receives the application did finish launching with options. Let's take a look at the application did finish launching with options by clicking in it and then selecting Quick Help over in the utility area. Application did finish launching with options tells the delegate when the application is launched. It's simply a convenient way to have your delegate know when the application is launched and what to do at that point. And what your app delegate does is initialize the window and make it visible. And all this is done for you as part of the Xcode utility application template. The view controller is initialized with the application did finish launching with options method here, and you can use this method to do any other application initialization as well, such as returning everything to what it was like when the user last used the application. You also see that there are methods for the messages application will resign active and application did enter background. In fact, when the application is about to move from active to the inactive state, you would put code in here to pause ongoing tasks or disable timers. If the application did enter the background, you would use this method to release shared resources, save the user data, invalidate the timers, and store enough application state information to restore the app to its current state. Now, if your app actually did background execution, and when you come back from the background state into the foreground state, you can add code here to undo many of the changes made on entering the background. And when you get the application did become active message, this method here lets you restore any tasks that were paused or not yet started. You can optionally refresh the user interface. Finally, the application will terminate message is called when the app is about to terminate. Here's where you save your data if appropriate. Now, if we look inside the main view controller M file, we'll find the show info. Show info initializes the flipside view, and it does that by using the init with nidname bundle method. As you can see in Quick Help, it returns a newly initialized view controller with the nib file in the specified bundle. The nib file, of course, is flipside view, which is here. And there's our flipside view. This is what appears when the user touches the I information button, which you can see in the main view right there. As you'll learn, that's a UI button, and it's already provided for you. And we'll be doing a few more of these user interface elements a bit later. Now, your goal during the startup process with the application did finish launching with options message is to present your app's user interface as quickly as possible. Don't load large data structures that your app won't use right away. If your app requires time to load data from the network or perform other tasks that take noticeable time, get your interface up and running first and then launch the slow task on a background thread. If your application requires time to load data from the network, or if it needs to perform other tasks that take noticeable amount of time, get your interface up and running first. You can then launch the slower task in the background. You can display even a progress indicator or other feedback to the user to indicate that the app is loading the necessary data or doing something important, but at least the interface is up and running. And when the application did finish launching with options method is invoked on the right side, your app is in an inactive state. Unless your app does some kind of background processing, when your app becomes active, it will receive the application did become active message when it enters the foreground. That's when it becomes the application that the user sees on the screen. With iOS 4.2 and newer versions, an app can also be launched into the background. However, the My World app doesn't do any background processing, so we're not going to be doing that yet. And therefore, it really doesn't have anything to do in response to the application did become active message. The important message for this simple utility app is the application did finish launching with options method. Now, I mentioned the creation of the application delegate object. Let's take a look at the code behind that. In the header file, My World App Delegate conforms to the UI Application Delegate protocol. Basically, an application delegate object is usually derived from an ordinary NS object, which is the root class, the very base class from which all iPhone application objects are derived. But it can also be any instance of any class you like, as long as it adopts the UI Application Delegate protocol. The methods of this protocol correspond to behaviors that are needed during the application lifecycle, and they're your way of implementing this custom behavior. Although you aren't required to implement all of the methods of the UI Application Delegate protocol, every application should implement the following critical application tasks: initialization, which we just covered, with UI Application Main sending the application did finish launching with options method; handling events in the event loop, which I'm going to be covering later; and responding to interruptions at determination, which I also cover later.